and and it was a funny sight. And here's some of the again of the structures that we were improvising and building as we were going to span structures from one point to the other. And one good point we had was the slurry wall, the basement wall all around the World Trade Center. That was a wall that went from the top all the way to the bottom. So it was a very strong element that we could place a lot of load, vertical load on it. Okay, so we utilized that as much as possible so that we could place the cranes all over, or create roadways so that we could get closer to the debris with the cranes and other equipment that we needed. Okay, and here's a cribbing that we were using again to get the equipment close to the site, as close to the site as possible. Survey and monitoring plan, a plan that we called in of companies that had surveying equipment and or monitoring equipment, and they just one of the people respond in very unusual ways. There's a company from Germany that heard that we needed some electronic equipment, and they called. Now, how did they hear it? I have no clue. They called and they said, we have the equipment on the plane, it will arrive tomorrow, send someone to pick it up, and we did, and it was a beautiful equipment, and we installed it, and we didn't exactly know what we were doing, and then the next day they sent somebody to install it, and they installed it all around the site, and we were monitoring, and it was computerized so that they could actually record the movement of the walls or the steel or inclinometers to measure if the wall moves from the vertical position and so on, and assist us in monitoring the site. Additional life safety assessments that were beyond the collapsed buildings that people needed to occupy as soon as possible to minimize the economic damage, as you can imagine. Building envelope and facades, roofing, because this is the first line of defense. We got to keep the water out of buildings and the weather out of buildings. MEP systems, as I mentioned before, a lot of these systems were saturated, or some of them were definitely saturated with the dust. Those systems were useless. Some buildings have not opened yet because of that problem. Most of the buildings, they were able to shut the equipment quickly, and they minimized the damage, but we had to go in. Indoor air quality was a concern, so we sent engineers out surveying the quality of air inside the buildings, and dust and mold and contaminants and all that would be potential causes of problems beyond problems of structural instability and structural nature. We used established forms. We used, for example, an ATC form, Applied Technology Council, which is a body in California. They do a lot of earthquake assessment aids and forms and so on. And they volunteer, they send out their forms, and we use that with slight modifications as to, we use them, and we had people, so that there is some uniformity. I mean, you have 50 engineers, 100 engineers canvassing in Manhattan doing building surveys. You have to have some sort of uniformity so that same people or different people apply the same standards in analyzing and surveying buildings. And these forms came extremely, extremely handy. And of course, these forms would be evaluated by teams of engineers in our office. And furthermore, we had to go to the building department and give the forms. This is one of the very few times that I've seen building department cooperate so beautifully. They did. To their credit, they did. There were no objections. And if there were, we ignored them anyway. You may have heard a great deal about the slurry wall. It was a wall that was really a basement wall all the way around the site, okay? And this is a big mother of a wall. It's a few hundred feet length and several hundred feet width, and it goes from top all the way to bottom, about 75 feet down to rock. As I said, it had 6 basements, right? The World Trade Center. And this wall was of great, great concern to us. Because as you can imagine, a wall that's 75 feet high, it needs lateral support. How do you support that wall? It was supported by the floors, the basement floors. And once these floors are gone, what supports the wall? Nothing. Debris, perhaps. Maybe not. You don't know. So we had no clue. So just to give you an idea, this is the wall, and this is now after we started digging, okay? 1231, okay? This is now months later, okay? But this wall has a thickness of about 3 to 3.5 feet, and I will give you an idea how important it was, because once people started excavating, and again, people are eager to excavate 24 hours a day, and of course, all along, we had a concern that if you start excavating, what supports that wall now? It's a problem. And we would sort of bring the problem to the contractors, and they said, come on, it's 3 feet high, it can stand. I said, it doesn't really work that way. And one day, we get on the radio, well, you better send somebody down here because we saw something on the street, and it was a crack that was developing on Liberty Street. And by the time we got there, that crack was, you could literally stick your foot down the crack, and it was sort of parallel to the wall. And it doesn't take a genius to realize that the wall is moving now. So we said, oh, you guys are digging too fast. We told you so. And then we spent the next 2 days putting debris back against the wall so that we could stabilize the wall. Here's the wall. Its original construction, it's interesting how it was constructed. How do you construct a wall like this in the beginning? Excuse me. What you do is by digging what they call the blocks or the wells, okay, the rectangular 3-foot by 15-foot wells with specialized equipment, and you dig it all the way down, okay, down to rock. Now, it's really not possible to do that without the soil sort of falling in, right? So what you do, you fill the excavated well with slurry, which is really sort of a lean grout mix with a lot of bentonite, okay? So it keeps the soil from falling in. And you keep digging, and you put more slurry, and you keep digging, and you remove the base, and then you add more slurry, okay? As you remove debris from the bottom, you add more slurry, and it's always full with slurry, okay? And then after you reach bottom, and you go down to rock to the elevation that you want, and then you dig down the rock, and you go down about 2 or 3 feet so that you can later on socket the new wall into rock. You start placing concrete from the bottom, okay? And as you place concrete, because it's heavier than the slurry, it displaces the slurry and it comes up, and you are pumping out slurry. You're pumping in concrete and you're pumping out slurry. That's why they call it a slurry wall, okay? And you pump all the way to the top, and then once you do that, all right, before, sometime during that process, you lower a steel cage all the way down, you see that? And you place it down in the wall, or you can place it down before and then you put the concrete, okay? And that's how they constructed it, one piece at a time, all the way around, okay? Until they enclosed the entire site. And then they started the excavation within the slurry wall. And when they reached enough depth, let's say 10 feet or so, then they would drill, I don't have that picture, they would drill ties diagonally all the way down to rock and socket the ties into rock so the ties would support the wall from coming in. Steel ties, okay? And they would drill lots of steel ties.